Okay. Hi guys. This is the EDA workshop. I'm Selena.
Heck.
Okay, let's get started. So, what is EDA? EDA is the process of analyzing data sets to summarize their main characteristics, often using visual methods. So basically, you're just familiarizing yourself with the data, identifying patterns between variables, detecting anomalies such as outliers, and checking assumptions and hypotheses before moving on to more formal modeling. So basically, you're just preparing yourself, getting to know your data, and preparing everything for modeling. And our key objectives would be understanding the structure of the data, such as shape, size, and distribution, and then identifying errors, such as missing values, duplicates, or incorrect data types, detecting patterns, such as relationships between features or anomalies, and generating hypotheses, um, which helps you develop insights that guide your modeling decisions. And you can kind of just like explore with your hypotheses and do a couple tests if you want to as well. And then communicating your findings through visual summaries. So in this workshop, we're going to do an introduction to the data set, and then we're going to go over data cleaning and preparation, descriptive and comparative analyses, data visualization, advanced analysis, and feature exploration. And you can clone the GitHub here at this link. And then so here's like a look at the data set we're going to be using. So it's a Pokemon data set, and we have the index here, and then we have each Pokemon has a unique ID starting from one, um, a name, a type, and a secondary type, and then some stats such as HP, attack, defense, special attack, special defense, speed, generation, and legendary. So you can see we have a few like integers or like strings and like a boolean. And so basically when when you're looking at your data set, something to look out for are like the size, such as like how many observations and features, which pretty much means rows and columns are there in the data set. And in those columns, what variables are available. For example, we have like HP, attack, type, other stats, and stuff like that. And like the data types are the numerical, categorical, text, and sample. Oh yeah, so we'll look at some of the sample data in the from the Git. And oh yeah, if you haven't already, take a second to like clone the stuff and open it. This is what the notebook pretty much looks like.
Yeah, so over here we can see that we've downloaded the data set and then we're just printing out the columns. So we can see that we have a name, type, HP, attack, defense, etc. And then we're just getting some basic statistics of the numerical columns. So we can see the count, mean, standard deviation, the quartile ranges. And then if you just do .info, it pretty much gives you the same, so it tells you the type of the column. And then over here, we're adding a total feature, which is basically just summing up the statistics like HP attack defense. Yeah.
Yes. Okay. And then so next we're gonna do data cleaning. Super important because this ensures that analyses are accurate and reliable. So some things to look out for are missing values because some data points may be missing due to reasons like errors in data collection. However, for missing values, there are like lots of different types of like missingness. For example, you can have missing at random, not missing at random, missing completely at random, which pretty much means like it can be missing depending on like the data, the actual data, or like depending on another column, or just like actually like it's a mistake, or it can be missing by design. So basically, if you look at our data set, the only column that has missing values is the secondary type. And basically, this is missing by design. So it's not actually a mistake that there are missing values because every Pokemon has a type, but it can have a secondary type, but not necessarily. But we still want to fill in missing values with a placeholder such as none, or if it's numerical, you can use mean or mode or some kind of average so that it doesn't like skew the data, so it'll still be the same. And then other things are like duplicate entries because sometimes you might have identical rows due to repeated data entry and you just want to remove them. Otherwise, some data, like if you have like multiple Bulbasaurs entered, it'll just be overrepresented in the data. And then incorrect data types, such as sometimes numeric data can be read as text, like instead of having the number 65, it'll be the string 65, and you just can't do computations on that. Or another example is like date type is sometimes like read as a string, and then you just can't do computations with it. So you just want to convert the columns to the correct data types. But yeah, um, yeah.
Yeah. So over here we can see that we're checking how many of the columns have null values, and then we're just summing to get the count. And then we basically fill in the null values with none, and the none values with NA. And then we check for duplicate entries. Also over here we can see that there's no duplicate entries, but if there were, they would have dropped it.
Yeah. Okay. And then the next thing we do is like descriptive analyses. So basically that helps us summarize and interpret the data before diving into a deeper analysis. For example, just looking at like distributions such as like mean, median, minimum, maximum, standard deviation. Um, Group comparisons, like depending on what your questions are, you can compare different groups. For example, we'll do legendary versus non-legendary Pokemon. We can see how their stats compare or like average stats amongst like different Pokemon type. And then you can also look for outliers. So like see what kind of extreme values might be affecting our analyses.
Yeah, so over here we can see the descriptive analysis between legendary and non-legendary statistics. So we group by legendary and we see the mean of all of them. So we can see that the mean for legendary Pokemons for HP, that is false, is 67, but for true it's 92. And then if you scroll down, we can see descriptive statistics for primary types. So if we group by type 1, which is the primary type, we can see the average statistics. So for water, HP is 72 and speed is 65. But for steel, HP is 65 and defense is 126. Um, we can also see some stats by type 1 if you scroll down. Yeah, this is just the data frame for the above code. And then we can see the count for each type. So if you scroll down, we can see that water has the most number of Pokemons, but flying has the least number of Pokemons.
Okay, yeah. So then we'll go into visualization, which it just makes patterns and relationships in the data more apparent and easier to interpret. And a couple common examples are like count plots, which just shows the distribution of categorical variables. You can just see like how much of each data type you have. And then box plots highlights the spread. You have like the mean, median, quartiles, and like outliers and stuff. And then heat maps can help reveal correlations between numerical variables. You can see like how different variables are correlated, like how strongly they're correlated.
Yeah, so we can see the distribution of Pokemon by type. So over here, we can see that water has the most number of Pokemon and flying has the least number. This is just a visualization of what we saw above. And then we can see in the box plot that the comparison between legendary and non-legendary Pokemon. So the median for falls, the ones that aren't legendary is around 75, and the ones that are is around 115 maybe. And we can see that there's some outliers as well on top. And then if we look at a pair plot, we can see the correlation between defense, attack, and HP for all the Pokemons. And this is just a heat map that shows the correlation to the above graph. So it's just another way of expressing the graph above.
Yes. Okay. And then, then we'll talk a little bit about advanced analysis and feature exploration. So basically, advanced techniques allow us to have deeper insights and open up new perspectives on the data. And in this workshop, we'll be talking about scikit-learn, k-means clustering, and a little bit about feature engineering. So basically, what is scikit-learn? It's a powerful Python library for machine learning and data analysis, and it can do things such as like classification, regression, clustering. And basically, it's helpful because when we're making a model, for example, if we're doing like regression, you don't have to actually like build the code to do the regression. You can just give scikit-learn, it's like an API, so you can give it your parameters and stuff, and it will do the regression for you. Your job in this case is just to find the right features and find the right parameters to make the model good, but it will do like all the calculations and the work for you. So it's an easy to use API for common machine learning tasks, and it integrates really well with Python libraries such as pandas and NumPy, which you'll definitely use a lot if you haven't been right now. And so we're gonna use it for k-means clustering to group Pokemon based on their stats. So what is k-means clustering though? It is a unsupervised machine learning algorithm, which pretty much means that you're using unlabeled data as opposed to supervised learning, such as like classification and regression. And it groups data points into a specified number of clusters based on their similarities. So basically, how it works is that first you choose a k number of clusters, and you can choose as many as you want. So imagine you have like a bunch of data points like spread out in a graph, and then let's say we want four clusters. So you randomly put like the four cluster centers somewhere. And so you assign the points. So each data point is assigned to the nearest cluster center. So whichever uh, center it's closest to, you just assign it to there. And then since these clusters were random, you want to update um, the centers. So you'll calculate the cluster center based on the mean of the points in each cluster. So for all the points you have, you take the mean, and then you move the center to the new location, which is the mean of that current cluster. And then you repeat this because then now you have to reassign the points because now different points might be closer to different cluster centers now that they've moved. So then if one point was closer to one before, but now it's closer to another one after it moved, you reassign it to the new closest center, and then you re-update the mean. But then you just keep redoing this until the clusters stabilize, so basically the models converge and no changes will be made anymore. And so we use this to identify patterns and natural groupings in the data, and this is useful um, for exploratory analysis when labels are not available, just like any supervised algorithm. And when we do it, we'll do it with Pokemon. We'll group Pokemon based on stats such as HP, attack, defense, and speed. And finally, we have feature engineering. So this pretty much means creating new features or modifying existing ones to improve analysis or model performance. So basically, when you have features for a model, you can start by using just like the columns you have, like HP, speed, attack, defense, stuff like that. Those are all features that you can use. You can just use the columns. But when you're trying to make the best model, you want to find the best features that are the most predictive of what you're trying to find. So sometimes just the columns by themselves are not the best features to use. So we can do things such as summing stats. For example, we'll combine HP, attack, defense, and speed. So instead of looking at everything separately, we're like, what if we just take the total power, like how strong the Pokemon is overall? And maybe that's more predictive or helpful towards what we're trying to find. Or otherwise, there's also transformation, such as scaling features for consistent analysis. And basically, For example, we can do standardizing data because sometimes the data is like we have different types of data and they'll be on like different scales or measured differently. And we don't want like the different numbers to like skew our model. But yeah, other things you can do, like sometimes you can take a ratio of two different features. So you can do like attack to defense or attack to speed and see how like um the ratio of like two different features can affect your predictions and stuff. But yeah.
Yeah, so over here we're using scikit-learn and k-means clustering to do what Selena said. So we're going to group our features by HP, attack, defense, and speed. And then we're going to, so what standard scaler does, it just standardizes it like a normal distribution. And then we fit it to our features. And then we perform k-means clustering. So over here, our number of clusters is 3, and the random state we picked is 42. And then we can just do dot fit predict, which does the k-means clustering for us. And then we can just plot it out. So if you scroll down, you can see the green, orange, and blue dots are 3 separate clusters. And these are Pokemons that have the similar attack to defense ratio. We can see that. And then for feature engineering, we can create a column called total power, which is basically a sum of all of the numerical features that we had. So HP, attack, defense, and speed. And we can sum them and we can create another feature called total power, and then we can analyze that. So it just gives us more information about the data set, and it's a better way to just explore the data set. So this is just a distribution of the total power versus the frequency.
Nice. So yeah, basically EDA is the foundation for any data science project because before you do any modeling or anything, you really need to get to know your data, make sure you know what you're looking at, like, and you want to understand like the connections between different features and different like parts of your data and stuff. And also clean data is super important because you want accurate and meaningful insights. You don't want data that's like misrepresentative of what you're actually looking at. And yeah, and then use visualization to help uncover hidden patterns and communicate findings effectively. That's all. Thank you so much for
Thank
watching.
you. Thank you.